So today we'll discuss about session 25. Session 25 is called as in blackbody radiation called as solar constant and estimation of solar constant and estimation of surface temperature of the star. Now in this we'll determine understand what is solar constant and we'll estimate the solar constant and estimation surface of the sun. So what is solar constant? Solar constant is defined as the amount of heat energy received per second per unit area of a black body surface placed at a mean distance of the earth from the sun in the balance of atmosphere, the surface being held normal to the direction of sun rays. Solar constant is denoted by capital S and its value is found to be 1.34 kilowatt per meter square. So this solar constant can be determined by Armstrong pyroheliometer. Pyroheliometer is an instrument used to measure the quantity of heat radiation and solar constant. Pyroheliometer designed by Armstrong is the simplest and most accurate. The Armstrong pyrometer consisting of two identical strips S1 and S2 as shown in figure of radius of area A, capital A, one junction of a thermocouple is connected to S1 and other junction is connected to S2. A sensitive galvanometer is connected to a thermocouple. The strip S2 is connected to an external electrical circuit as shown in figure. When both the strips S1 and S2 are shielded from this solar radiation, galvanometers show no deflection as both the junctions are at the same temperature. Now the strip S1 is exposed to a solar radiations and S2 is shielded with the cover M. As the strip S1 receives heat energy from the sun, its temperature rises and the galvanometer shows a deflection. Now the current is allowed to pass through the strip S2 and it is adjusted so that galvanometer shows no deflection. Now the strip S1 and S2 again in the same temperature. Then if the quantity of heat radiation that is incident on a unit area in unit time on a strip S1 is Q and A is the absorption coefficient, then the amount of heat radiation absorbed by the strip S1 in a unit time is called as QA into small a. And also heat produced in a unit time in the strips 2 is given by V into I, where V is called as potential difference and I is called as current flowing through it. As heat absorbed is equal to heat produced, therefore Q capital A small a is equal to V into I, or Q is equal to V into I divided by capital A into small a. By knowing the values of capital V, capital I and A and small a, Q can be calculated. That is called as solar constant. We can determine by using this equation easily. So next is called as estimation of surface temperature of the sun. So let capital R be the radius of the sun and capital T is the absolute temperature of the photosphere of the sun. The amount of energy radiated by 1 meter square meter surface of the sun in 1 second is given by E is equal to 4 pi S into R square divided by 4 pi R square, that is equal to capital R divided by small r whole square into S, where R is called as mean radius of the sun from the earth and capital S is called as solar constant. According to Stephen's law, E is equal to sigma T to the power of 4. From equation 1 and 2 we can write down capital R by small r whole square into S is equal to sigma T to the power of 4. Or we can reduce the T is equal to capital R by small r whole square into sigma S divided by sigma whole to the power of 1 by 4. By knowing capital R, small r, S and sigma, the temperature of the sun can be easily determined. So by knowing these values, the temperature of the sun is found to be 5755 Kelvin. So thank you.